Well, hey everybody, welcome. This is Anthony Sequeira and this is stormwind.com, as you could probably just figure out from that really scary intro. And this is the much awaited, much anticipated, much requested part 2 of our look at zone-based firewalls. And I want to thank everybody for their feedback on session 1 and all the requests for this session 2. And my apologies for getting wrapped up with a whole bunch of things before getting this out to you, but here it is as promised. Let's jump right in. I know your time is valuable, so we're going to be very precise and focused here in this presentation and get you that information that you're looking for. You remember last time in part 1, we had a lot of fun taking a look at the configuration of zones and zone pairs, looking at interzone access policies, right? When we want to control the traffic from one zone to another. Intrazone access policies, we talked about those last time, that are an improvement on the zone-based firewall, allowing you to literally control what happens within a zone. And we left 4, 5, and 6 for today's session. We left them, honestly, because we had so much to cover. We wanted to give them real adequate coverage here. We're going to do basically 3 things. We're going to look at the SelfZone today. Yeah, I feel good about myself, and so does the zone-based firewall. The zone-based firewall has a SelfZone, and this zone is going to be used to control traffic that is coming from the router or traffic that is going to the router. You might say, what would be traffic coming from the router? Well, how about things like routing protocols and other control forms of traffic? How about us making a secure shell connection from our router to something else? Or how about us reaching a TACAX Plus server from our router? These are going to be things that are impacted by the SelfZone. Something else that we're going to learn to do in this particular session is go in and tune the inner workings of the zone-based firewall. You're going to love that. And finally, we'll talk about things like transparent mode and zone-based firewalls interacting with VRFs, virtual routing and forwarding tables. And how about the zone-based firewall and what would happen in a NAT-based environment? So all things that we are going to examine in this particular part 2 of our zone-based firewall discussion. First, control plane and management plane traffic. Yeah, there is this SelfZone, and it's certainly what we would use to deal with the control and management plane of the router. Again, traffic going to the router and from the router's own IP addresses. You see, the zone-based firewall is able to statefully inspect this traffic thanks to the SelfZone. Now, you probably remember from the last class session that we didn't create any SelfZone on the device. Is this SelfZone created automatically? And the answer is a resounding yes. It is created automatically for us. So one thing we don't have to worry about doing is creating the SelfZone. Now here's one of these big fancy charts from Cisco. We prettied it up a bit here at stormwind.com, but still, it's just a big chart. What does it mean? What is it trying to tell us? Well, let's go through it line by line and decipher it. If the source interface is a member of the SelfZone, okay, and the destination interface is a member of some other zone, and there is no zone pair in existence, and therefore no policy in existence, the resulting action is that we permit the traffic. I guess this is a way of saying that, the SelfZone can communicate with any interface that's in any other zone. Yes, in fact, that's exactly what it's saying. In fact, look at the second line. If a zone pair exists and there's no policy in place, we still permit. And if the SelfZone exists and the destination interface is a member of a zone and there's a zone pair and a policy exists, we're going to apply whatever policy map actions result. What we're saying here is this really? And you can reverse it like they've done. You can reverse the logic like they've done in the last 3 rows. What we're simply saying here is this. Look, by default, the SelfZone can communicate with all your interfaces, just like all your interfaces can communicate with the SelfZone. It's a permissive security model by default. That only makes sense, right? Cisco wanted to make sure the router could engage in its control and management traffic functions if you went in and engaged in a very powerful zone-based firewall configuration. Yeah, the default is permissive here. Now notice what this chart tells us though. We can indeed go in and apply policy map actions and allow them to take effect for traffic sourced from the SelfZone and for traffic destined to the SelfZone. So this big fancy chart tends to confuse a little more than it helps us, right? And there's our explanation of it. Look, by default, it's permissive going to the router and coming from the router if we want to control the SelfZone in either direction, we can. So it's no surprise here that our configuration tasks when we're dealing with control plane and management plane traffic are really going to deal with configuring inbound policies for the SelfZone and configuring outbound policies for the SelfZone. And notice these are completely optional configuration steps, aren't they? Because we don't have to do any of this, do we? No. In fact, I suppose we could say that the entire zone-based firewall is optional too, isn't it? Okay. So let's go ahead and do 2 things. Let's set up a configuration scenario for our SelfZone. And I also in this video want to review with you the zone-based firewall configuration. Why not? Sure. I realize that it may be a while since you checked out that part 1 of our video series on the zone-based firewall, so we'll go ahead and do some fun review. Here's going to be the scenario that we set up. We're going to have an outside zone, a DMZ zone, and an inside zone. And in the inside zone, we're interested in making sure that the SelfZone can ping the inside zone. We are interested in making sure that the SelfZone can communicate bidirectionally with a TACAX Plus server. And finally, we're interested in making sure the inside zone can do SSH and ping into the SelfZone. But notice we want to be restrictive with the outside zone and the DMZ zones. And again, the manipulation of the SelfZone gives us this particular capability. Okay, now let's go and set up a scenario where we can go ahead and test all this stuff. And I'm going to show you this exact configuration scenario that we see on screen's configuration. But again, before we jump into any of that, I thought it would be very valuable for us to just kind of review some things here. So I created this R2 device, and the R2 device, notice, is going to be our zone-based firewall. And we're going to experiment, of course, with that SelfZone. So I went ahead and titled this particular device Self. Yeah, it just happens to be R2. By the way, for those of you that might be interested in creating this scenario yourself, well, you certainly can. I used 4 routers in this scenario, 1 to represent outside, 1 to represent DMZ, 1 to represent inside, and 1 to represent the zone-based firewall itself. And if you wanted to follow along exactly as I'm doing, interface for interface, you could use the equipment up at proctorlabs.com. Yes, I am on a Proctor Labs rack right now, on a route switch rack from Proctor Labs, and I am doing this demonstration. If you wanted to do this on the CCIE security rack from Proctor Labs, you could as well. So either of those two racks, CCIE route switch, CCIE security, and you could follow along letter for letter, if you will, with this demonstration. All right, so here's what we need to do. First of all, you would never want to progress with a demonstration without testing some things. Does our zone-based firewall, does it have connectivity right now unrestricted with everything else? Well, can it ping the outside device? The answer, yes it can, okay. Can it ping a device in the DMZ? Let's see. Yes it can. And finally, can it ping a device on the inside network? That would be 10.1.1.49. Yes, it can. Notice I am using, in this example, the numbering scheme that Cisco often uses in their education materials. The 192.168 private network represents the outside, 172.16 represents the DMZ, and 10.x represents the inside network. All right, do you remember how easy it is to configure the basics of the zone-based firewall? Yeah, let's see. We say zone security and we create our zones. Here's the inside zone. Then we can say zone security and create our outside zone. And then we say zone security and we create our DMZ zone. Now, by the way, if we were to say show zone security at this point, we see, aha, there's that SelfZone. Yeah, there's that SelfZone. I didn't create it. The zone-based firewall itself created it. And they even go so far as to say, hey, Anthony, you didn't create this. We did. This is a system-defined zone, and it's going to be used for that control and management traffic. Well, okay, so there's our zones. There's multiple, there's different ways you could configure this thing, but you know me, I like to come up with a way in which I'm going to configure it, and then I do it that way all the time. I call this my cadence of configuration, and, it's just the way in which I learn to do it, and it improves my speed of configuration. It improves my accuracy of configuration. So here we go. I'm going to go to the zone-based firewall, and I'm going to go to the interface that connects to the outside world. That is serial 020 in Proctor. And I'm going to say zone security, you are outside. And then I'm going to go to the interface serial 010, and this connects to the DMZ. And I'm going to say zone security, and you are inside. Whoops. No zone security inside. What I wanted to say here was zone security DMZ. And then finally, interface gigabit 0/0 is going to be our zone security inside. So let me just recall that from the buffer. Okay, did I do this right? You know me. I like to go ahead and verify, configure and verify in what I call my baby steps. Yeah, because I'm a huge fan of that movie, What About Bob, from the 1980s. So here we go. Did we do it right? Yes, we've got the appropriate interfaces in the appropriate zones. Now you recall from version 1 or session number 1 of our two-part series on zone-based firewalls, you remember that this has a profound effect on things now, doesn't it? Yeah, now that we have our interfaces in zones, if I go into the inside device and I try and ping the outside world, I've got news for you, folks. That's not happening. Yeah, that is not happening. And trust me, this ping would have worked prior to us doing those zones and interfaces. Now, can we ping to the zone-based firewall? This would be proof of the SelfZone and its permissive structure, its permissive model. Can we ping to it? Well, if I ping the 10.1.1.2 interface on the zone-based firewall, you notice that we can reach it. This proves that that SelfZone is indeed permissive by default. All right, now let's finish up just from a review perspective. We want to finish up our zone-based firewall configuration. We've configured our zones. We have placed the appropriate interfaces in those zones. Now we do our policy language, right? To do something. I'll just give a simple example here. We tried to ping from the inside world to the outside world, and we just saw it didn't work. And that's because the interfaces are now in zones. So we'll just quickly allow the inside to do all of ICMP. I know I'm being a bit lazy here. Ping would not just be ICMP in general, but let's just be a bit lazy and we'll just allow all ICMP traffic to be statefully inspected from the inside world to the outside, and we'll see that we can now ping again. By the way, I am going fast here, and the reason why I'm going fast here is because we covered all of this in the first part on our two-part zone-based firewall series. So just realize we are going fast through this, it's just review. All right, I'm going to create a class map, first step. And this is a class map of type inspect. And we are going to name this class map CM_ICMP. We are going to match on the protocol ICMP. Our next step is we're going to create our policy map. We're going to create a policy map of type inspect, and we'll call this PM_ICMP. And we are going to reference the class CM_ICMP. And we are going to say inspect this traffic. Next up, we are going to create a zone pair. So I'm going to say zone pair. And yes, zone pair security, and I'm going to name it in to out, and our source zone will be inside, and our destination zone will be outside. We are going to attach a service policy of type inspect, and it is PM_ICMP. Notice we don't have to specify a direction because the directionality is implicit here because we are specifying the source and destination zones. Well, we now go into the inside network and we retry that ping that failed earlier, and the ping is successful. But was it really the zone-based firewall that did it? Let's check. We're going to do show policy map of type inspect, and we want to examine this for our zone pair, and aha, it was definitely the zone-based firewall configuration that did it, because we can see here that we are currently inspecting, packets for that particular transmission, specifically its ICMP packets that have been inspected. Notice there is the class-default, of course, like we would expect to have in our policy language. This catches all the traffic that we didn't define by default, and we can see that there are no packets that have been dropped due to this class-default at this point. All right, great. So a nice review there to get us up to speed. Now, if we look at our configuration scenario, none of this really conveys what I just did, right? I mean, let's remember what we just did in our review. We made a policy so that the inside could ping through the zone-based firewall to the outside. That traffic would be inspected, and then the appropriate return ping traffic could return to the inside. Yeah, that's what we did. What our configuration scenario here is asking is for us to do a bunch of manipulations for traffic either bidirectional from and to the device or unidirectional either from the device or to the device. Well, it's easy. Look at how easy this is to do. We are going to create classes that, once again, dictate the particular traffic that we are going after, and we are going to tie these into a policy map, and we're going to tie this into a particular zone pair. So let's walk through it step by step. Here we have some access lists that can define the specific transactions that we're interested in. Notice this is ICMP coming from the inside IP addresses, and we're doing specifically ping. I like it. Traffic coming from the inside IP addresses going specifically to SSH. Because we said in our scenario that we wanted the inside devices to be able to communicate via ping and SSH to our zone-based firewall. We go ahead and we create a class map of type inspect called into self class. I like it. And we tie in the access control list that we created to define the acceptable traffic. We now create a policy called into self policy. We reference that class map that we created and we inspect that traffic. What do we do with everything else? Well, this is shown here just for illustrative purposes, but this would have been the default. We drop any other traffic destined to the zone-based firewall. We now create a new zone pair called into self. We source the traffic, of course, from the inside, the zone pair, excuse me. We source inside to the self zone. And I like how they put that in all lowercase because it was actually created by the system. And then we tie in the service policy. The service policy that you can see we tie in here is the into self policy. Wow, so simple. So amazingly simple. And before we do anything else, before we show you the remaining configurations for our scenario, let's jump up to the machine and make sure this actually works, why don't we? Yeah, let's jump up to real gear. I never trust anything, right, unless I see it working with my own eyes at the command line. So I jump up here and I say, okay, R2, we proved a moment ago that devices on the inside could ping to you. What about a device on the scary outside? Can it ping my zone-based firewall? 192.168.1.1. No, the zone-based firewall would be at .2. Oh my goodness, outside people can ping my firewall. Yikes, don't want that at all. So we can come in here and we can say, all right, let's see, there's many ways we could do this, right? I can say, wow, there's so many ways you could do this when you think about how this self-zone could be constructed, right? One of the things that we can do is literally create any basic policy to the inside zone, to the self zone, right? And I'll block all ICMP, but you realize you could go in and you could distinguish what traffic forms are acceptable from the outside world to the router. And that's really what you would do in the real world. You would say, all right, I want this, this, and this to be acceptable from the outside world. Probably would be very few protocols. And then you could allow the class default in that policy map to police out of existence ping, for instance. So you would allow ping to fall into your class default bucket and be denied. In our quick little example here, we'll pick on ping. Now, it seems to me we already created a class map that matches on ICMP. Yeah, we sure did. So I can reuse that. These things are reusable, aren't they? Of course they are. So watch this. I can say policy map type inspect, and I can say PM underscore block ping. And now I can reference my CM underscore ICMP class. We're reusing that class, and I can say drop. Yeah, I can say drop here. Now, I exit, I go and create a zone pair, and this zone pair is named out to self. The source is the outside, the destination is the self zone, and I say, look, here's the service policy of type inspect, and it is named PM underscore block ping. So you see just how easy it is to manipulate the self zone. Now, this thing blocks everything the way I constructed it for right now, but it's just quick for illustrative purposes. And we try and do that ping that we did earlier that succeeded. And of course, the ping fails. Yeah, because we have a policy in place now to control traffic to the self zone. Well, let's continue with our particular configuration scenario. Remember, in our configuration scenario, we wanted everything else denied, right? All inbound sessions from the DMZ and the outside zones denied. So notice we have a simple deny all policy here that leverages the class default action of drop. And notice we added the log keyword. So we're going to get to log the people that are attempting to communicate to our router to see who those attackers are. We set up a DMZ to self zone pairing, and we put in this deny all policy. We set up an out to self zone policy, and we bring in the deny all policy. So very powerful. We set up the self zone so that other attempts to communicate with it from the outside or the DMZ are dropped and logged. Now, finally, we need an outbound policy for the self zone per our requirements. We said the self zone, the router needed to be able to do ping out. So here's our definition of ping out traffic. We said it needed to be able to contact a TACAX Plus server. So there's the definition of that. We create the self to in class map. We create the self to in policy map, which is going to inspect that traffic and drop and log everything else. And then we create the appropriate zone pairing and assign that policy. So, you end up with quite a few zone pairings once you start thinking about that self zone. You know, you've got your in to out zone pairing and policy. Now you've got your in to self zone pairing and policy. You might have your out to in, and now you got your out to self, your DMZ to in, your DMZ to self. You get the idea. Probably be a really good idea for you to document clearly the zone pairings that you have in plain English and the things that you are attempting to accomplish with these various zone pairings. Some more guidelines for you when it comes to engaging with this self zone. Well, yeah, obviously you want to reverse the logic that Cisco has given us. You want to reverse the logic, and you want to make sure that it's a restrictive structure instead of a permissive one. Yeah, you want to reverse that logic, make it restrictive, and punch holes into it for those things that you actually need. Remember, we don't want stateless communication with the device using protocols that we might need for the router to achieve. We want to convert them to stateful. Yeah, we want to statefully inspect these sessions. And remember, if you don't do anything with the SelfZone, you have that entirely permissive policy. Look at this good student right here. She's reading all about the SelfZone. You know, this is the first time I've worked with the SelfZone. Normally, I'm working a lot with self-help. Yeah. All right, let's go now and take a look at the second objective that we had on tap for today. And that second objective was to do what? It was to learn how to tune this thing. You can tune a piano, you can tune a zone-based firewall, but you can't tune a fish. Two bad jokes right in a row. Normally I don't do that. You'll have to forgive me. All right, so here we are in the tuning area, and this is really awesome. What you can do is you can go in and you can control the timers on garbage collection. Yeah, normally your device is going to be good about going in and it will be good about saying, okay, that session's over. Let me clean it up. You know, it'll do that based on FIN, or it'll do that based on resets. Okay, reset flags. It'll go in and it'll clean stuff up. But you may want to be able to go in and say, you know what? This connection's been hanging around too long idle. I want to grab it and garbage collect it. Now you got to be careful here. Cisco has gone in and it's tuned your zone-based firewall to the exact settings it thinks should work beautifully in most environments. If you go in and you try and get too aggressive with this, you could cause major issues for applications. So just be aware of that. Here are the default inspection timers that Cisco felt were most appropriate. They felt these would give the best balance between security and allowing applications to function properly. So just keep in mind that these default settings have really been tuned with a lot of thought. They weren't just arbitrarily created by Cisco. Now, there's also a TCP Normalizer function that you probably realize is in the zone-based firewall. It's great. It can go ahead and reassemble streams and then make sure that they're not violating the TCP protocol. These are, the TCP Normalizer is really an anti-evasion technique by the zone-based firewall. It's like, hey, look, I know what you'll do. You'll break up things in the TCP segments and you'll try and evade my application inspections. If I'm, inspecting HTTP applications with the zone-based firewall, I know what you'll do. You'll try and evade me by breaking up that attack over multiple TCP segments. And again, the zone-based firewall says, nice try. I can go ahead and normalize the TCP traffic and make sure that these attacks are not coming into our network. Well, again, as we're about to see, we can tune this normalizer behavior. Well, how do you do all this? Well, we can do this with parameter maps. Okay, we can use parameter maps to define special inspection settings. Now notice we apply parameter maps here to tweak the inspection, or better word would be to tune the inspection behavior, but we can only do it, of course, logically, we can only do it when we are inspecting traffic. Yeah, it makes sense, right? If we were just passing traffic as the action item, then we couldn't go in and apply these unique inspection parameters. So when it comes to tuning your zone-based firewall, you're going to go in and potentially, all this is optional, configure stateful tracking timers. You're going to configure session logging potentially. This is called auditing. You're going to tweak the connection limits. You're going to tune TCP normalization parameters, as we talked about potentially. And you can even tune the port to application mappings for specific applications. Well, let me show you a scenario in which we'll engage in these tunings. We've done our homework and we know we've got to tweak. We've got to tune our zone-based firewall for our environment. We want to go ahead in this scenario and log all FTP sessions. We want to tune the SYN timeout to 10 seconds, the idle timeout to 2 hours, and the FIN timeout to 30 seconds, and we want to allow up to 500 sessions. This is for the outside zone using FTP into the DMZ. Wow, how awesome the way we can tune just that particular protocol behavior. Now, on the zone-based firewall itself, we want to globally inspect the FTP traffic also using port 2121. You see, we've decided to use port 2121 for FTP, so we have to tell the zone-based firewall to realize that FTP is on that unique port number. And then finally, we want to go to the TCP Normalizer, and we want to make sure it buffers up to 50 segments instead of whatever its default is, and we want to make sure it buffers them for up to 5 seconds each. So what do? Well, to manipulate the timers, notice we do it in a parameter map. Now I like it. This is the first time we've seen a parameter map. So we create a parameter map, surprise, surprise, no surprise, of type inspect, and we name it my params. We then go in and set the fin wait time, we set the idle time, we set the SYN wait time. And notice you'll tie this parameter map into your inspect action. This isn't a surprise for us because remember, we said that in order to enact a tuning of the zone-based firewall, we would be doing it on traffic that we inspected. Notice we said we wanted to do auditing or logging of the FTP traffic. So notice in this same parameter map, we turn on auditing, right next to all the tunings of the timers. And of course, this is applied in that same my params parameter map to the inspect statement. Notice in here, we go in and we can set the maximum number of sessions to 500. Now, the other thing that we wanted to do in this scenario for tuning the zone-based firewall was to globally tune the TCP Normalizer parameters on the router. Remember that? Well, we have to create a parameter map now of type yeah, that's it. Of OOO specifically. It's not ooh, baby. It's OOO, and that is a type of out of order. Yeah, the parameter map type is called out of order, or abbreviated OOO, for tuning the TCP Normalizer parameters. Notice this is a global parameter map, isn't it? We go in, we turn on alerts for violations, we set the queue length to 50, and we set the timeout per queuing buffering behavior to that 5 seconds. So this is how we are going to globally manipulate the TCP normalization parameters. And finally, very simply and also done globally, we set up our port application mapping for the TCP port 2121 to also match FTP. Some guidelines for tuning of your zone-based firewall. Only tune when you need to. Yeah, I mean, really, that's the whole advice column here. Only modify these settings that Cisco has carefully set for us. Modify them with extreme care. You got to have a really good reason for doing it. Because if you don't have a really good reason for doing it, well, then you could cause your application to break, or on the flip side of that, you could end up creating massive security holes in your infrastructure that you just didn't want. Well, folks, you've been great. Let's wrap up this session with a discussion of transparent mode, zone-based firewall, of virtual routing and forwarding, and NAT support. Well, great news. If you wanted to have the transparent mode firewall, the zone-based firewall, act as a bump in the wire, you can. Yeah. We know that traditionally, we're going to set this thing up as we have in both part 1 and part 2 of this class, set it up in routed mode, where it is routing, right? It's got a subnet on one side of it and a different subnet on the other side of it. But we could operate in transparent mode, where it is participating in the subnet, and the common way in which to refer to the firewall acting in this manner is called a bump in the wire. You know, it's almost Halloween time right now as I record this class for you live. And by the way, we've got some live students in the audience, and as always, I want to thank everyone for their attendance and their participation. They're chatting with the mentors about their questions, and I always love the fact that stormwind.com does these events live on the internet for our students to enjoy. But I'll tell you, it's Halloween time right now. We're getting close to it, and we usually talk about bump in the night. But this is a configuration that's not a bump in the night, it's a bump in the wire in this transparent mode. These devices just aren't aware of it, but it is doing layer 2 firewalling for us. Now, it's certainly not routing traffic, but what it is doing is it's acting like a transparent bridge, and it is forwarding traffic now based on MAC addresses. Yep, no longer scrutinizing IP addresses, it's operating based on MAC addresses. So how would you do this? Well, I'll tell you how you do this. You're going to set up integrated routing and bridging on your iOS router. Yeah, look at this. We may not have seen this configuration in a long, long time. You're going to set up integrated routing and bridging with the bridge IRB command. You're going to enable both spanning tree protocol as well as IP routing on this bridge group, and you're going to construct a bridge virtual interface. This bridge virtual interface is going to get an IP address, and then we're ready to rock and roll with the transparent mode configuration. Notice, once you've got the integrated routing and bridging set up, notice you're not doing anything all that special. You're creating your zones, you're putting your interfaces into zones, and you're utilizing the bridge group in order to apply the IRB configuration to these interfaces. So very, very clever. In order to get the transparent zone-based firewall, you are going in and you are configuring IRB in conjunction with zone-based. How about our virtual routing and forwarding environment? Well, great news for you. The zone-based firewall is completely VRF aware. Yeah, it's completely VRF aware. So you're going to have like here a VRF in engineering, and we can create our zones off of it. Here we have a VRF called test, and we can create our zones off of these VRF aware interfaces. So any kind of additional knowledge of zone-based firewall is not required. Here we create virtual routing and forwarding tables. We assign those to particular interfaces, and then we go ahead and we create zones and apply those zones to the appropriate interfaces. The zone-based firewall is VRF aware, so no additional, worry is required on your part for these configurations. The only tricky thing, obviously, about this is you've got to, again, document everything really, really well, right? I mean, now we're adding another layer of complexity, aren't we? With the virtualization of the routing tables and the interfaces, we're just adding that additional layer of complexity that you're going to want to make sure you have fully documented. And finally, NAT. More great news regarding network address translation. You see, when we're doing NAT, we create and configure NAT, and then all we got to remember to do in our zone-based firewall configuration is to refer to local addresses that are communicating across the firewall. So we don't have to take into account any of the NAT mappings when configuring these firewall rules, because the router automatically identifies the correct traffic flows even if those addresses are also mapped using NAT. Let's take a look at an example. So we come in here just and construct a simplistic example for you so you can see this. IPNAT inside source static, we are going to statically translate 10.1.1.21 to 201.165.2013. Next up here, we have our access list defining traffic, and you notice what we did. We referenced the real or local IP address. Yep. We don't go by the mapped one, we go by the real or local IP. We then create our class map, we create our policy map, and we apply the appropriate zone to the appropriate interface, and that interface would be flagged as the NAT outside interface, and we're going to be good to go with this configuration. Not shown here, obviously, is the zone pair and the application of the policy map to the zone pair, but I just showed the portion of the configuration that we care about, right? And that is, as is highlighted, this being the big portion. We reference in our zone-based firewall configuration the actual or local IP address in the NAT scenario. Well, folks, you've done an amazing job in these two parts on our zone-based firewall. And the last thing that I want to do is just leave you with a troubleshooting logic for when things don't go right. You know, one of the things about classes that we compress like this in a small time period, and by the way, normally when I teach zone-based firewalls at stormwind.com, we are going into much greater demonstration depth, but we're pressed for time in these little samples that I created for you. But, you know, one of the things that happens is I have to kind of do everything perfectly, right? Everything works beautifully because we really don't have time to make mistakes. So what I wanted to leave you with was this: a troubleshooting methodology that you could use for these zone-based firewalls. For instance, you think you've done everything right, but lo and behold, you can't establish a session through your zone-based firewall. My goodness, what could it be? Well, is your session allowed by a particular policy? I mean, that would be the first thing that you would want to check, right? We can use show policy map type inspect zone pair or zone pair sessions in order to discover this. Are we even allowing that particular session through as part of policy? If we are, okay, check our classes and the policy itself. Show policy map, type inspect, zone pair. Once again, awesome for this. Do we have the appropriate port application mappings in place? Maybe we're using a customized port that our router doesn't know about. Show IP port map is going to be our money command to check that. And then finally, verify proper inspection. What we might want to do now is debug. Debug policy firewall protocol and debug policy firewall list are two excellent commands that we can use to deep dive into the actual inspection routines that the zone-based policy firewall are engaging in. Now, a word of caution here. You can limit those debugs. To just particular hosts with an access control list. Yeah, as you might guess, whenever you are debugging with something like the zone-based firewall, which could be analyzing massive quantities of traffic, we want to go ahead and limit those debugs with an access control list so we don't overwhelm our device. Well, folks, I want to thank you so much. Thank all the live audience members that we had today. Thank all the live audience members from the last session. Thank you again for all the great feedback that we've received. And I hope you've enjoyed this two-part series exploring the zone-based firewall. We looked at it, by the way, from a certification perspective. We looked at it in the depth that you would need for things like the CCNA security. We looked at it in a depth appropriate for the CCNP security secure class. We looked at it in the depth that would be necessary for the CCIE route switch exam. And we really went a long way, but not fully, to the depth required in the CCIE security environment. So from a certification perspective, we certainly hit a lot of targets with this presentation. Thanks again, everyone, and I hope to see you very soon here in a live online class at stormwind.com.